Want to go next?
Yeah.
All right. Hi, everybody. My name is Laurent Gibert. My entire career has revolved around building game engines and product for real-time applications. I lead the product management teams at Unity for specifically dots and multiplayer area. I will be hosting this session today with Sam.
Hi, my name is Sam Smith. I'm one of the engineering managers for the game server hosting team here at Unity. My job is to take the services that have run some of the largest AAA games in the world and make them accessible to all of you. Thank you.
Thank you. So glad to be at GDC again this year, to meet you all in person, and also doing something that I love the most, which is sharing developer stories with you all. In particular, in this session, we will try to inspire you to build multiplayer games by walking you through 3 different stories of studios that have been shipping recent multiplayer titles. Hopefully, that's going to make the multiplayer genre maybe less scary to some of you. Also, just simply make you aware of some of the recent development we've been having at Unity for multiplayer. So I'll introduce our guests, and we'll start with our first game, Ship of Fools, which is a seafaring cooperative roguelite where you play a fool, a creator fool enough to brave the sea, and you try to save the archipelago from the aquapocalypse by sailing, manning the cannons, and battling sea monsters right through the tempest with your mate. It was released last November on Steam and consoles, Nintendo Switch, PS5, Xbox Series. Let's have a look to the trailer.
I set them to see how they fare. Storm Strider lighting the way. With only each other to stand by their sides, they kept foes at bay, at least for today. With danger approaching, they try and they try. The aquapocalypse ever raging topside. While relics of sirens they pull from the depths, unaware that their quest might lead them to their death. Our tale began with their heaviest storm. Now I'm afraid how it ends. Believe me, I've seen it before. The darkness that lurks in the eye of the storm. The darkness that lurks in the darkness that lurks in the eye. I guess we'll find out who's the greatest of fools.
So hi everybody, I'm Marc-Antoine. I'm the CTO or tech lead at Fika Production. We're a young studio located in Quebec City, Canada, and we're behind the game Ship of Fools. I was mainly working on the networking of the game during its production, so I'll be able to share some of our learnings today with you.
Thank you, Marc-Antoine. So now let's introduce our second game, Turbo Golf Racing. Turbo Golf Racing is an arcade-style sports racing game for up to 8 players online. It's the improbable overlap between golf balls, racing, explosive competition. Turbo Golf Racing is on the Xbox Game Pass, has game preview, Steam Early Access, and got, I think I got the number wrong here, over 1 million players already. That's fantastic. We've peaked at over 3,000 concurrent users. So let's see how it looks.
Good morning, everyone. I'm Andy, co-founder and tech lead at Hugecalf Studios. Turbo Golf Racing has been our first multiplayer title, so I'm very much looking forward to sharing some details with you today.
So great to have you, Andy. Thank you very much. And now, for the third game that we'll talk about today, Histera, a competitive FPS that mixes prehistoric settings with war-torn 20th century cities through time travel. Histera is currently in closed alpha and is expected to go into open beta later this year. Same thing, let's have a look at the trailer.
Hello, everyone. My name is Jamel Ziaty. I'm a producer at Stickylock, which is an international game studio headquartered in the Netherlands. And I'd like to thank Unity for having me.
Awesome, thank you, Jamel. So our conversation today will follow the journey of creating the game, launching it, and then scaling for success. So to get started on this creation process, we thought it would be useful to share your experience in choosing the right tool for the production. So we'll start with you, Marc-Antoine. You've worked with Unity's netcode for GameObject for Ship of Fools. How did that go?
It worked well. I'd say we had a good experience working with netcode for GameObject. And I can explain a little bit more in detail why we chose it. In fact, Ship of Fools was the very first game we developed as a game studio, and for me as a game developer. We knew from the get-go that we were going to make a peer-to-peer game because of the type of the game. A two-player cooperative game that's not too demanding in terms of physics, didn't need a dedicated game server or sophisticated matchmaking system, nor did it need an anti-cheating system because of its cooperative nature. If you'd be cheating, you'd only be cheating yourself. We didn't need any crossplay capabilities, and the prospect of not having to pay for service fee was really appealing. So we compared netcode for GameObject, which was in pre-alpha version 2 at the time, to other netcode solution. There was Mirror and Fishnet that was pretty similar feature-wise, and Photon, which was more feature-rich, but its free version forced us to use its Photon Cloud solution for our relay server, and we really wanted to stick to using free services. And even though netcode for GameObject was in pre-alpha, it wasn't a new product. It'd been around for several years as ML API before being taken over by the Unity team. And it made it all the more interesting to us because it kind of guaranteed us that the framework would evolve in the same direction as our game engine. And the fact that it was an open source project mitigates its lack of features by allowing us to develop our own. Yeah, with that being said, there was several challenges working with a framework that is actively in development. First of all, the documentation was often outdated or sometimes missing. We had to regularly consume their source code, monitor the new commits that was merged into their master branch, read their code reviews, and get involved on the Unity Networking Discord. And yeah, getting involved in the Unity Networking Discord was a really good way to broaden our thinking on all aspects of networking a game, because we didn't necessarily thought of everything since it was our first game doing networking. And another challenge was that because the Unity team was kind of wanting to stabilize ML API before bringing in new features, we lost a lot of feature, and sometimes we even had to freeze part of their code base to ensure that we kept what we needed for our game. And the way we worked with their package in the beginning was by creating the missing feature directly in our game project and updating their package as new update came along. But the solution even if the solution solved a few problem, it wasn't optimal because it forced us to inherit their component and sometimes only to apply bug fix. So what we've ended up doing is creating a fork of their project to make it evolve as we wish. And that worked well. We could easily rebase our libraries patch as soon as Hugecalf arrived and drop commits that brought additional restriction in our project. So I would say that we were able to do everything that we wanted with netcode for GameObject, and we learned a lot about networking working with it.
Yeah, maybe I should mention at this point that since then, the overall netcode for GameObject has been released. So now it's a fully supported feature with all the documentation and everything. But yeah, it's always challenging to be an early adopter of a technology. But at least the team has been very grateful of having you being a very active member of the community on Discord to help us like nail this down. So turning to you, Andy, I believe adopting early technology wasn't a choice you were ready to make for TurboGolf Racing.
Yeah, you're totally right. As you can imagine, the new packages coming out of Unity were really exciting for us. They did everything we needed, the physics and the netcode, but none of us had any experience with dots, so we were kind of flying in the blind a little bit, and we really actually struggled to get off the ground. We did a lot of discussion and a lot of prototyping, but ultimately we just couldn't replicate the existing car mechanics we had in our prototype. So this made the whole decision-making process really hard because we had this holy grail which did everything we needed and wanted, but we couldn't really figure out how to use it. And we knew that picking any other tool was just going to be like a lesser solution to those packages. So we had to just guide our decision-making based on what we knew we needed and wanted. And those were the possibility for player interactions, whether it was going to be full-on car collisions like you see in Rocket League, or something lighter touch like firing missiles at each other, which is what we actually ended up with. And the other thing we wanted out of the box was anti-cheat, because around this time, Fall Guys had come out and the cheaters were having a field day, and we didn't want that to be possible in our game. So we took our early prototype, which was client authoritative, and compared it to those requirements, and immediately it falls flat on its face, because any player could just teleport their ball into the hole, and they'd win. And unlike Mark with Stripper Falls, you're not just cheating yourself, you're like 7 other people who are playing competitively. It's going to ruin the game. And obviously adding in cheat detection is always an option, but what we saw was just that the cheaters would always be finding the next loophole, and you'd just be chasing them all the time. And even forgetting about cheating, car-on-car kind of high-paced physics collisions are just out the window with client authoritative. So we also looked at other products like Photon, but we were put off by the lack of clarity of what was actually possible with these packages and things like cost. And we also had a desire to learn about how netcode worked, like how it actually worked, not just how to implement someone else's package, but how did these systems work behind the scenes. So that is why we ultimately chose to make our own server authoritative netcode, which sat on top of the physics engine and the Unity transport package. And as you can imagine, it's been one hell of a ride, but we've come out the other end with a working game, and we're really proud of it. So yeah, it's been great.
It's really a bold move to actually take the development in your hand and come up with your own solution on top of it. Jamel, on your end, you fully embraced early technologies for Histera.
Yeah, we definitely did. And I'd like to detail a bit more about how we came to that conclusion or to that result. So when we first started out, we knew we were making a multiplayer FPS game. And we knew that peer-to-peer just wouldn't be a proper networking solution for us, for the same reasons as you heard from Andy, basically competitive advantage and also security. We knew that we wanted to roll with a dedicated game server, and we knew that a dedicated game server would even have its own set of challenges regarding security. However, at the time when we started with Histera, we were a very small team, and we had little to no networking knowledge. So we were looking at options for solutions or packages, libraries, anything basically. However, this was in a period where the networking solutions and options were quite barren. We didn't have a lot of options to choose from. There were no first-party solutions either. But there was a Unity blog post, and it showcased a roadmap showcasing that the Unity netcode package was hoping to be stable by Q2 to 2021, I believe. And if you were willing to work with preview packages, you could even adopt it earlier on with all disclaimers and risks for yourself, of course. So around that same time, they also released a sample, the FPS sample, and also the dot sample quickly after. And we were quite fascinated by those samples because they were technically a proof of concept of making an FPS game with dots. And also using the Unity netcode packages, which was very valuable for us. So we dove deeper into those packages, and we also became very fascinated with dots itself. The data-oriented approach instead of the object-oriented approach was very valuable for our programmers to learn basically what was going on and having more control over what's happening, basically. So as bold as my colleagues are at Stickylock, we chose to invest into our knowledge on dots. And in some cases, even double down. So yeah, it was a tough journey getting to learn dots for multiple aspects, for multiple reasons. The shift in paradigm, onboarding designers and artists onto the stack as well. And yeah, the preview package, you don't have any support, and you might miss certain features that you either need to roll with the punches or you need to implement yourself. So it was very interesting.
So same thing here. It's good to mention that now ECS has been made ready for production. So it's supported in 2022 tech stream and for all the platforms of Unity. So now that's stable. So now that we kind of went through a little bit of the choices, like thought process for the solutions, it would be good to understand a bit better how you architect your game. So let's get back to you, Marc-Antoine, again with Ship of Fools. How did that go from an architecture point of view?
Ship of Fools is a peer-to-peer game, and even though there's no dedicated server between the players, one of them will act as both a server and a client. That player is referred to as the host. And one of the key things that we must define when designing an online game in terms of netcode is defining where the truth lies at any given time. And in peer-to-peer context, there's a certain asymmetry in what is perceived by both players, especially because the host experiences no latency in validating its own state with himself, unlike the remote client. So to overcome this situation, we need to employ a slightly different strategy and sometimes even more complex truth control strategy than with a dedicated server. And we have illustrated on the slide here the networking architecture of Ship of Fools. Something that can be seen on the left in client authoritative is that each client in our game owns its truth about its played character. That means that if the remote client moves its character to a given spot, it doesn't need to validate the action with anyone. The goal here is to make the control as snappy as possible for every player. On the right, in the host authoritative section, we have some element of our game whose truth is governed by the game host. That means for the client that if a client would be interacting with one of these elements, such as a shop to buy an item, he'll have to send its request to the host, and the host will then either validate it or invalidate it, depending on the case. For instance, if the crew doesn't have the funds to do the purchase collectively. And if we were to let the client prescribe this truth, we will end up having some bad situation where two clients would allow to make a simultaneous purchase of of two different items, even if there's not enough funds to both purchase at once. And there's an interesting boundary that lives between the client authoritative and the host authoritative element when we're talking about things that involve physics. Sorry, I'm getting back to that. Sorry.
Is that okay? Do you want me to try to scroll down a little bit?
Yeah. Get back.
I hope that I know where the mouse is. Oh, it's over there. Sorry, we make the notes too long for the actual size and the screen.
Yo, okay, so it's in the other slide. Okay, yeah.
Should I switch?
Yeah. So, oh yeah, okay, yeah. Some example of that is where when a player repels an enemy with his paddle, or like we see on the screen here, when he pick up an item in his hand and throws it back on the ground. On the left screen, we have the remote client screen where we see its character that is controlling. And on the right, we have the host screens seeing the same character. The item, the little seashell that we see on the screen, when it's loose in the environment, has its world position governed by the host. On the other hand, when it's held in the character's hands, we cannot continue to synchronize its world position in a host authoritative way, since the character is client authoritative and will therefore move locally on its side before the host replicates the movement. And that will cause the item to follow the client, but with a slight delay. And that's something that we don't want. And also, as you can see, the fool's animation is not quite synchronized. We didn't need that. You can see it by the ups and downs of the hands movement. But we wanted the item to follow the bones of the character's rig for the best immersion. So we added the solution of using parents constraint, base Unity component, to lock the item to the character's end. And we stopped the synchronization of the item's position while it was being carried. So on any client, the item would perfectly follow the character, whether or not the client governs its route. And yeah, it's on the other slide. Yeah. So, and what happens regarding the launch of the item? If we were to do the physics simulation on the host side and then replicate the result on the client side, we end up with the same situation where we have an initial latency at the beginning of the throw on the client side. And that's not something that we want. So what we've ended up doing is doing the local simulation on each client and then sending the same starting simulation parameter to the host to replicate it. And as some of you may know, Unity's physics is not deterministic. There can be some errors, some numerical errors changing the course of the simulation on two different clients, even though they have the same starting parameters. So what we've been doing is we've detected the collision of the item with the grounds when the throws was finished. And we start to resynchronizing the item in a host authoritative way. And we correct the small difference between the two truths by interpolating the item position, which gives a slight sliding effect upon landing. So in summary, there's a lot of artistry involved in juggling with sources of truth when architecturing a peer-to-peer online game in order to obtain the best game feel and a coherent experience.
It's really interesting how peer-to-peer seems like it's going to be a little less complex, but still you have those challenges of truth management. Andy, with TurboGolf Racing, you get that definitely additional level of complexity with the dedicated server. How did you architect the game?
Yeah, so it's really interesting actually, because on the one hand, you don't have to worry about all those multiple sources of truth. So in quite a few cases, it really simplifies it. The source of truth is what the server said, and that's that. There's no confusion. But on the other hand, by moving that authority to the server, you also inherit the physical limitations of networks, namely latency, and it's dealing with that latency where we gain a lot of complexity. And we can actually have a quick look at a simple logic diagram for authoritative server here. So every frame, the client on the left will gather inputs from the input device, put them in a packet, and send them to the server on the right. The server is then going to step its simulation using that input, and it will then create what we call a snapshot, which basically describes the entire state of the whole world. And we send that back to the client on the left, where we can display the results of the simulation. However, this does not take into account latency. And if we look on the next slide, we can see what adding the time dimension does. So now the input and snapshot packets take time to traverse the internet. And this means that there's a large period of time between the player providing their input and them seeing the result. And in a lot of games, this breaks the tight feedback loop you need to control your character. And believe me, in TGR, hitting your ball is hard enough without any input lag. So this definitely broke our game. So in order to combat this, we can add, we also simulate the inputs which we send locally at the same time as sending them to the server. And you can see that labeled prediction here. So now to the player, the car now feels responsive again. They've got the type feedback loop back. But why is it called a prediction? Well, this is because we don't know the entire state of the world on the client in this frame. We don't know the remote player's inputs in this frame because they haven't arrived yet. They're still coming across the internet. And those inputs could definitely affect us. So all we can do is a best guess, and that's why it's called a prediction. But in TGR, this prediction is correct most of the time because we don't do a few things. We don't have direct car-car collisions, and we also don't simulate or predict remote players at all. And they're the situations when that prediction's mainly incorrect. So in fact, there's only really a few situations where those predictions are wrong, like if I were to fire a missile at you, you would predict wrong. So we still, in this case, need to determine if our prediction is correct. So how do we do that? When the server sends its snapshot and it arrives on our client a few frames later, we can check. So on the client, we simulate frame 1 and send our inputs to the server. The client then simulates frame 2 whilst the inputs travel across the internet. And at this point in time, several things happen at once. The client will simulate frame 3, and the server will also receive the inputs from the client's frame 1, which it can simulate for itself. And as a result, we get the snapshot, which we can send back to the clients, where it will arrive a few frames later. Now, the client is on frame 5, and we've just received the snapshot for frame 1, and we can compare the results of these two to detect if our prediction was correct. If they do match, we don't have to worry about anything, and we can carry on as usual. However, if they don't match, then we consider our frame 1 prediction to have been a desync, and we need to do something about it. So the client's on frame 5, but it's just found out the prediction for frame 1 is incorrect. So how do we deal with this, considering we're now in the future from when that prediction was made? Well, firstly, we need to do a rollback. And this consists of, as we see on the next slide, this consists of taking the snapshot that the server sent us and applying it to us on the client, which effectively resets us to frame 1. But now we're at frame 1, where we were previously at frame 5, so we need to catch back up. And we do that by re-simulating multiple physics frames. And that sounds simple, and technically it is. We literally just loop several frames. But this means that in a single frame, we're now doing several simulation steps, and that puts very, very tight time constraints on our simulation code in order to maintain 60 FPS. So if you're thinking about making a server authoritative game, there are 2 videos you need to check out, and if you go on our Hugecalf Studios Twitter, you'll see links to them now.
That was a great explanation. Thank you very much. Jamel, how does that compare for the architecture of Histera, which is also the server authoritative?
Yeah, so the explanation from Andy was amazing, so I'd like to thank him again, because we also use a dedicated game server architecture. So it's quite similar, so I won't reiterate on the same point for Histera. However, regarding general networking architecture, you might also wonder how other clients get simulated. So I'll detail how that's done basically within Histera. So the other clients are basically packed within the snapshot that the server sends over to the client. And you could, on the client, of course, apply that data that you receive from the server within the snapshot directly to the other clients. However, in that case, it would look like the above visual in this slide, where the other players are basically jittering or being directly positioned or rotated on their new state. So what we choose to do is basically get the older states and interpolate between the older 2 states. This way we can ensure that there's more smooth action, you can see smooth movement from other players, as this could also be tampered with network package loss or network jitter or latency, or even the variable frame rate of the client being much higher than that of the server. This is called client-side interpolation. Another thing that's very useful for Histera from a general networking architecture standpoint is that we have collision worlds. However, I'll come to that later in this presentation.
Excellent. It's been, I'm having some weird notes in my slide, I'm sorry. I'm not sure what's going on here. So we talked about the architecture of the 3 games, and then we talked a little bit about the fact that the packages are being open and that you could extend the functionality that you need to deliver. So for Ship of Fools, Marc-Antoine, you did that a lot with netcode for game objects.
Yeah, we did. One of the first things that comes to mind that we did is integrating with the addressable system. At the time, there were no support for addressable within the framework. And at some point during the production of Ship of Fools, our scene loading time were getting longer and longer, and netcode for game object was kind of aggravating the problem. In fact, when switching scene in an online game context, netcode for game object wraps Unity scene managers in order to sequence the loading of the scene. He asks the host to load its scene first, and then the host instructs clients to load their scene afterward. He does that because he needs to assign a network identity to the network objects that are part of the newly loaded scene, and he needs to inform the client of these network identities before they in turn activate their scenes. So that effectively gave a scene loading that was about twice as long as in than a scene loading that is in a normal local game context or local multiplayer context. So at this point in the development of our project, we decided to use addressable to start loading up elements in memory only when they were needed. And that worked well. We save our loading we reduce down our loading time to about a third of what it was. And I think you have to switch the slide to, oh, there's a slide missing. Okay, it was the other one. Okay, yeah, good. So yeah, one of the things was that we couldn't use netcode program object to do scene loading with addressable scenes because it has no knowledge of our addressable scene that were in addressable groups. So through our library fork, we had to implement a deterministic ways to register those scenes and make it use the scene manager that is part of the addressable system package, not the Unity built-in one. And we even went one step further by achieving scene preloading on the client side, so that when the host instructs the client to load a given scene, the client only had to activate the scene rather than completely loading it. So that helped a lot. And in fact, I could talk about many other things, many other aspects where we extended netcode program objects for specific needs, things like Unity timelines or doing a dependency injection upon network prefab spawning. But I think we would exceed the length of this talk if I did so.
Indeed, managing data for the game, particularly in multiplayer context, is something that is very complex. And Andy, with TurboGrafx Racing, you got in trouble with data management over the network.
Yeah, we definitely did. And this was because we have to send that full snapshot from the server to the clients each time. And we have to do that because our physics simulation isn't deterministic and we don't simulate remote players. And in our game, the cars and balls have a lot of systems running on them, and each system has a lot of state in it. And in order for our rollback system to work, every single piece of state has to be sent. And for us in the early days, that meant our snapshot was over 6,500 bytes, which over the course of an hour was over a gig of data, which wasn't necessarily a problem for us developing the game, but we knew that real world, it was just going to lead to bad experiences and bad reviews. So we knew we had to improve it. And to do so, we built an editor tool, which we can see here. So this worked by instrumenting each call into our byte writer class. And that allowed us to inspect the stack every time we wrote bytes. We could see which line of our code was writing the bytes and how many bytes was written. And this allowed us to really drill down into the packet and see who the bad offenders were, because So using this tool, we were able to get our packet size down to a quarter of the size at 250 meg per hour, which is still quite a lot, and probably wouldn't run on this conference center Wi-Fi, but yeah. It was a big improvement for us. So on the topic of state, we also came across another interesting problem using rollbacks with the physics engine. So the state of a physics engine should just be the pose and velocities of all the bodies in the scene. However, physics engines often cache state between scenes as an optimization and to also provide extra features. And these normally work fine, but it's based on the assumption that each physics frame is ahead in time from the last. And rollbacks just throw that out the window because we're suddenly just taking state from a few frames ago. And we don't have access to this cache state. We can't reset it, and we can't ask it to be, we can't manually set it ourselves. So it leaves the engine in a really weird, undefined state. As an example, you can see here that the car is moving forwards each frame. In the third frame, the car collides with the ball, and the built-in on-enter callbacks are triggered. However, if we roll back at this point in time, something really interesting happens. Because the car is no longer colliding with the ball, the on-exit callbacks are invoked. However, this is not what we want at all, because that collision hasn't really ended yet. It hasn't even begun yet, because we've gone back in time. And this is really bad, because that on-exit callback is never called on the server, so it leads to non-deterministic behavior. Next slide, please. Yeah, so through experimentation, we discovered that the on-trigger stay callback was the only safe one to use. But you can do a lot with it, because if you store your own state to track whether it's the first or last frame of the interaction, you can straight away get your on-enter, on-exit callbacks back, but now you're in control of all the state. So that was a really good discovery. And problems like this, which cause non-deterministic behavior, are the enemy when it comes to making games like this. And it's very hard to hunt down sometimes what is causing it. So to help us, we made another editor window. And this one allowed us to compare the state for each frame on the client with each frame on the server. And it would do a text diff of both those states and visually color where the differences were. And this really helped, because as soon as you knew which data was different, you could then figure out why it was different. And this was an example of a tool which just saved us so much time, because we could just get such a good window in on the data. However, this was a tool we could only use when running the client and server together in the editor, which is a really unrealistic situation, because normally the two are physically separated. The client is on the client machine and the server's on that server, which leads to all sorts of problems like events leaking between the two of them. The server fires an event and suddenly the client's reacting, but it should really just have no idea that event was ever fired. And another funny problem we get when running the two together, we can see in this video here, a car is just jumping around like crazy. And this is happening because the client car is overlapping with the server car because they're in the same physics scene, and it's trying to continually resolve the collision on both those cars, but they move to the same place the next frame, and the same thing happens. But thankfully, this one's an easy fix, because you can just load each scene into its own physics scene, and then there's no interactions, because they're in different worlds.
So I guess we could add around determinism of physics as part of the ECS stack. Now we have also a physics engine that is stateless, that is fully deterministic. So that would have helped most definitely here. But unfortunately, it's being done later, and we weren't jumping on early technologies on your side. So maybe for the sequel. Jamel, for Histera, did you get that ECS benefit of this client-server separation Andy was referring to?
Yeah, the ECS package helped us tremendously in that front. Within ECS, you have separation of worlds by default. So in this example for here, you can see that we basically go into the server world and we change the weapon of the other client at runtime. And adjusting this data is very valuable for us, and it's also possible due to the world separation that we have, basically due to ECS. This is also on like the 0.50 package, which enabled reading during runtime of data components. However, before that, it was read-only, which is also very valuable to us for debugging mostly, checking the state on the client or other clients on the server compared to the client. Was very useful for us to see if certain things were wrong and in what world specifically they went wrong. The dot sample package that we basically used to jumpstart Histera was very useful for us, as it had all the components or all the features that we would need. It had ghost fields, it had prediction and rollback, it had quantization and serialization, it had RPCs. So it basically was like a complete package for us, which was very useful. Especially like the ghosts, prediction, and rollback structure that was available in the sample was great for us because we didn't need to worry about that complexity. Even though we did need to understand it, it was very valuable for us that it was available from the get-go. And I'd also like to go into more detail about other aspects from Histera. So on this next slide, we have prediction being showcased. So what we have here is basically slow-mo footage of a gun shooting. One version is from about a year ago, where we have server authoritative bullet impact. And you can see that it takes a few frames for the bullet impact to showcase on the left side. The reason we did this was so that the player would get all the information, or like the actual information about where the bullet ended up in the perspective from the server. However, we quickly came to the realization that it felt very clunky. It wasn't really snappy. And as a player, you basically want that feedback as soon as possible, even though it's less accurate. So in the end, we chose to make it predicted. And on the right slide, on the right side of the slide, you can see that as soon as you shoot, you directly see the bullet impact, which does wonders for the player feedback. Then another aspect within Histera is the glitch. The glitch is our USP. And what the glitch does, it basically changes a section of the map to a completely different era. So a completely new layout that the player can basically play in. And when we started Histera, we thought that the glitch would be a challenge regarding networking. However, when we actually started implementing the glitch, we came to the realization it isn't actually that bad to implement it for the networking part of it. However, the things that we most needed to, or the biggest obstacles regarding networking for the glitch was making sure that late joiners are also glitched, that they don't have like a completely different state of which eras are active currently in the world. As well as 2 consecutive glitches happening quickly after each other. We need to make sure that the data is not wiped and that it is then basically transitioned into a new era. We did have a bug where we would have like the collision world of one era and then the visuals of another era, which was quite a funny bug that we had. And then finally, our biggest challenge for Histera on the next slide is showcasing hit registration, which is always a big challenge in shooters. So on the left side, you can see like the ideal scenario where the blue gizmo collision rig is basically the server side, and the green gizmo collision rig is the client side. You basically want the collision rigs as close to each other as possible and as much overlap as possible, so that when you shoot on a client, you're basically determining or you're sure that you're also hitting him on the server. However, in certain use cases, when developing Histera, it was more like the right case, where the server and the client were very separated from each other, causing a lot of desync. And making it very hard to actually do damage to other players. To go a bit more about the technical aspects of this and why collision worlds were very, very interesting and valuable for us. So you do have the input, as Andy stated, and it gets basically sent to the server. The server does the simulation with that input, but within the input, we also save the tick that the client basically perceived. And then with that tick, we can basically go back into the collision world history, and we can grab the collision world that we want to test against, because we want to test against the world or the collision world that the client saw when he shot, not when it's basically being simulated on the server. However, you also don't want to go back too far, because then people will just have benefit from having lag. So you basically want to have a threshold of how far they can go back, and that part is called lag compensation.
So, gentlemen, we learned a lot about the creation aspect of the multiplayer game. Thank you very much for those super explanation about it. So Sam will take over the conversation right now to lead us into how you were choosing the infrastructure for the various services and how implementing those services into your game. Sam?
Thank you very much. Well, thank you, Laurent. Choosing infrastructure service providers obviously can be a bit of a daunting task sometimes. Marc-Antoine, since you didn't have any infrastructure for that peer-to-peer architecture, we'll go straight over to Andy for this one. Andy, obviously, as we said, slightly different for TurboGolf Racing versus Ship of Fools. Could you walk us through that investigation and discovery phase, and then how you came to using like PlayFab in combination with game server hosting for Unity?
Yeah, sure. So for talking about server hosting first, we actually came across Unity game server hosting quite early on. And we went to a meeting with the team where they showed us their hybrid approach. And this was great because to us and to everyone, dedicated servers normally mean high cost, and you need to accurately know how high your peaks are, otherwise players won't be able to get into games. However, the hybrid model, which allows kind of the base level of players to play in bare metal and to scale into cloud, is great because it means less cost, and it doesn't matter how high your peaks are, because it just automatically creates new resources when you need them. So this was great, and we were sold from the beginning because we knew that was just a good flexible approach. And then coming to service provider like PlayFab, it was, to be honest, quite a default choice. In an early prototype, we needed player login accounts, and we found PlayFab, so we implemented it. And since then, it's done everything we've needed, so we've just kind of kept it in. But we definitely would like to have everything under the same hood. That would be lovely to get that Unity matchmaker in.
Well, we'll definitely pick up that conversation later. And that's great to hear, Andy. Thank you. So it's also good to highlight in that how Unity gaming services can be used in combination with other providers to build the ideal setup for your game and what you want to do. So Jamel, developing Histera, how did you figure out whether to use dedicated game servers like Andy did, or that peer-to-peer architecture like Marc-Antoine? And who did you want to use for those services?
So due to the nature of FPS games, we knew we needed to roll with an authoritative server, of course. And a base reason where we have chosen for using those Unity game services is that we wanted basically to be focused on the core gameplay. We wanted our devs to basically work on the actual game itself instead of all the infrastructure around it. And we also wanted to ensure that we had something that we know, that we basically have trust into scaling. In case we get traction, of course, we want to basically have it able to be scaling up. So that was very useful to go to Unity Gaming Services, as we knew you guys had the expertise basically to deliver that. And if we would have built it ourselves, I'm not sure how long it would take us or how stable it would be. But yeah, so it was very valuable to us.
Oh, that's great to hear. So you guys have now, you've chosen your providers, or you've chosen that sort of multiplayer solution you want to do, whether that's dedicated game server or whether that's peer-to-peer. So let's talk about integrating those services together and integrating those into the game. Marc-Antoine, we'll come to you first. You chose to integrate with each of those first-party providers. Did that present any challenges to you?
I would say that apart from the pleasure of reading the not-so-human-friendly documentation of the consoles, it was pretty straightforward. Something that the netcode framework does really well is that they focus on serializing game state and sending the state through network packets that network transport will route between the players. So they allow us to interface with any kind of services like what the first party offers. And for us, it was, we thought that going with first party services like Steam, Nintendo, Sony, and Microsoft was strategically good expertise to get as a young studio by getting our hands dirty in platform native SDKs. And in the case of a netcode for game object, they exposed an interface for network transport, and that's what we did. We used it to implement the glue between the network transport for each of the first party in ship of fools. And as illustrated on the slide, for each platform or consoles, we use the native connection protocols, which was very often a UDP connection, which use in a completely transparent way either NAT traversal technique like stun or relay servers to ensure a successful connection between the players. And one thing that's great is that each of those platforms offers these relay servers that are distributed all around the world for free. And to know to which client to connect to, we've been using game invitation systems, which is kind of a basic matchmaking system that we can use to connect to friends from that are in each other's friend list. So that's what we did basically, and yeah, that was pretty straightforward. Yeah.
Oh, that's great to hear, and I guess it allows you to add other platforms as they potentially come online in the future without needing to rework that existing code, which must be really nice. So Andy, you mentioned you're doing that dedicated server thing. We talked about how you chose to use PlayFab and game server hosting. How was actually the integration of those two together?
It was actually surprisingly simple. We've got a diagram here which shows everything we do. So I'll just take you through that now. So on the left, you can see that when PlayFab gives us that match found event, so when PlayFab's found that group of players to play, we start doing two things. On the clients, we start polling a piece of shared data which they can access and the cloud code can access. And whilst that's happening, the cloud code requests the server from Unity. And when we get given that IP and that port for the server, we can put that in that shared piece of data which the clients are polling. And as soon as the clients detect it, they can then connect to the server. And it's a really simple setup. This has been a piece of code which has been in the project for years, and it just continues to run smoothly. So it's been a really simple process.
Nice, and that's great to hear. Thank you. And so, Jamel, you're in a much earlier phase of that game development lifecycle. You're only integrating with UGS, as you mentioned as well. And so how has that integration been for you? And do you find that going with that single provider has made it easier? And then do you see yourself sort of extending into the wider UGS suite as you go forward?
So the integration of the UGS services was quite easy for us. It went quite smoothly. We had a few hiccups here and there. However, the support from Unity was also always there to basically help us out, even if it was our lack of knowledge or our wrong implementation in some cases. They were available to help us. So that was very valuable to us. For example, we had a closed playtest and the backfill stopped working, so matchmaking put them in new servers, and we basically had Unity support on call directly, and they helped us out, and we had backfill enabled pretty quickly, basically. Besides that, we're looking, of course, to we have game server hosting, we have matchmaker, and then we're also looking at VFox and possibly Unity Friends to add to our collection, basically, of Unity services. And I'd say it's very valuable to have it under the same roof, because we've also noticed that once we shoot in a ticket through like game server hosting, for example, they can also identify, oh, this is more a matchmaking issue, and they'll pass it along to the matchmaker team without us having to basically grab the ticket again, put it back to matchmaker. So that's very valuable to us, as well as having no glue code needed. Basically, we don't need to structure anything. We don't need to maintain certain glue code. So that's very valuable.
Oh, fantastic. And it's great to have all that support and expertise in one place, right? And then the option to expand into other areas of UGS. So Mark, peer-to-peer, obviously different challenges, and in some cases, you're kind of beholden, as you said, to those first-party providers and what they expect you to do or what they want you to do. Could you speak about some of the constraints of those providers, and then whether scaling infrastructure has any problems on their side for you?
Yeah, sure. Obviously, scaling infrastructure wasn't a concern for peer-to-peer. As long as we as player, we have servers. So servers that are going down or permanently shut down isn't risk that you face when working in peer-to-peer. But that being said, what can affect our players' experience is their internet connectivity, so the distance between them, and in some case where in some remote location where a relay server is used to achieve the connection, the distance between them and the remote server can affect their experience. And generally speaking, using a relay server to ensure the connection will always offer a worse experience than a direct connection, because you have a middleman in the middle, so the distance for the network packets is longer, obviously. But something important that is great to know is that some platforms will de facto use a relay server instead of trying to make a direct connection. Steam does that, and it allows the player to opt out of this behavior in their settings. They can, I think the settings call allow games that are using Steam networking to share your IP with the person you're connected to. And if you allows that, basically that will opt out of the relay servers, and they will attempt a direct connection. And that may sound bad, sharing your IP, but it isn't really if you're just connecting to someone that is part of your friend list that you already trust.
Yeah, absolutely, and that's fascinating. So Andy, infrastructure, clearly more of a concern for you. How did you prepare that launch and that sort of scale up as you came into launch? Did you find any bottlenecks in the system during your testing?
Yeah, we were thankfully able to identify quite a few bottlenecks, things like high resource usages and crashes at certain points in the game. And thanks to performance testing that Unity carried out on server builds we gave them, we were able to identify these early on. And this was not only great for player experience, like preventing crashes, which would just kick all the players off the servers, but it also allowed us to fit more server instances on each machine, which would keep our costs down. And we were also able to prepare for launch by carrying out a scale test, which allowed us to validate our matchmaker, our glue code, and the server allocation. So we did this by providing a thin client, which could literally just create a matchmaking ticket and connect to a server. And then that got installed on 1,000 cloud instances, which were started over a 10-minute period. And after that test, we were able to look at the graphs and validate that every single cloud instance got connected into a server, which was just great proof for us that we were ready for launch and our glue code and all the other services worked. And at launch, we got an even bigger scale test as we hit 3,000 CCU, it was amazing watching everything scale as expected until, unfortunately, our Azure glue code caught fire, and you can see what happened.
Oh, thanks, Andy. And it's great to know that the team have been really good working with you, that sort of scale up, scale down. And actually, I spoke to the team earlier. They loved working with you and really enjoyed that experience. So Jamel, obviously, as we said, much earlier in that development phase, have you started thinking about scaling yet? And how have you been preparing to launch Histera alongside the Unity hosting team?
So we haven't hit like our major milestones yet. However, we've been testing with scaling just a little bit. We've done some like very small closed alpha playtests, usually around like 50 to 60 people. However, moving on to like the next milestones like open beta and early access, first we are probably going to test in closed alpha still with like around 100. And then from open beta and early access, we expect, of course, like a lot of people. However, we are also quite confident in Unity game services and scaling. So yeah, we're not scared or anything. I think we're very prepared. I think.
Nice. Well,
and then besides that, we also, what UGS also offers is basically the statistics and data that you can see. This example showcases statistics from Matchmaker, where we can see how much time people are waiting to create a match or find a match, or how many of those matchmaking allocation tickets are basically being made. So it's also very useful for us to get insight on what's currently running, how is it currently running, and is anybody getting stuck in certain loops. So if something bad happens, at least we got the statistics as well to basically grab it as soon as possible and fix it.
Yeah. Well, Jamel, I know I'm excited to play Histera. It sounded like a commission to all of you to also try and play Histera when it comes out. You touched on some of those other services you were thinking about there, and I want to take a few minutes to highlight some of the other UGS services. I'm sure you might have seen this slide in the previous talk. There's a massive amount of services here, right? You've heard our speakers today touch on some of them, namely hosting, Matchmaker, Vivox, Friends, and a couple of others. And we could spend the rest of the time here talking about all of the analytics, DevOps, and ads tools to help you build your game and make it a success. But we are very quickly running out of time. UGS allows you to work the way you want. It's engine agnostic and allows you to integrate with those other providers, as some of the guys here have highlighted today. You can scale with AAA proven services and get started entirely for free. My colleague Joshua is going to be back on this stage, I think it's the next talk after this one, to talk more about some of the other services available in UGS, and then some use cases and how to work with them. So do come back and find out that one. Laurent, what was your takeaway from the session?
Yeah, thank you. So from the Unity engine creation point of view, going through all those 3 games today with Ship of Fools, that's the casual co-op kind of games where you have netcode for game object with the UGS services available, up to Histera, with action competitive games where you have netcode for entities, with game server hosting and Matchmaker and all those other services for UGS. Or even if you need to have a very custom solution with your own custom netcode, like TurboGrafx Racing has been doing, we have already, like in between Unity 2020 RTS up to 2022 tech stream that are available right now and supported for production, the solutions to help you create and launch those games. There is also an additional announcement that I would like to make quickly today. To help with the creation of multiplayer games with ECS, we thought that it would be useful to actually build an actual sample that would make it easier for you to pick up. So we're preparing an actual demo of Megacity multiplayer with 64 plus players that is currently in the work, that is pre-integrated with a bunch of services from UGS, game server hosting, Matchmaker, and voice chat, a couple of those services. And we are working hard at trying to make that demonstration available to you very soon.
Oh, that is exciting. So the final thing for me to say is let's know where we can hear about some more. So Marc-Antoine, where can we learn more about Ship of Fools?
Yeah, Ship of Fools is available currently on Steam and all the latest console. You can join our community Discord to learn about all the upcoming development for the game. And this week we're at the Unity booth if you want to come and have a chat with us.
Awesome. Andy, how about for TurboGrafx Racing?
Well, we're on Game Pass for PC and Xbox. We're on sale on Steam currently, and I'm excited to announce a free weekend on the 20th of April. And also, please just come join the Discord and have a chat.
Amazing. Jamel, how about for Histera?
Yeah, please wishlist Histera on Steam. We're going in open beta later this year. And join the Discord as well.
Fantastic. Well, on behalf of myself, Laurent, please join me thanking Marc-Antoine, Andy, and Jamel for sharing their story with us today.